Yes. So basically, PWM signal is a pulse width modulated signal. That is a one type of modulation that we use for the to change the speed of motor or to control the on and off time. Okay. So the signal should be like that. The width of the pulse, like if we are saying about the digital signal, so digital signal should be represented in the form of 0 or 1. Okay, digital signal should be represented in the form of 0 or 1. Now, if we represent a signal 0 and 1 where the width of the pulse will be changed. Okay, so every particular instant we can say that this is a T on, T off. So every time you can see the T on and T off time will be varying. So that signal is the pulse width modulation. Now we know that when we use the operation amplifier with the positive feedback, okay, we are giving two signals and we provide a positive feedback. Okay, so that we already discussed in the week 4. If the operation amplifier will operate in a positive feedback, so it will be the output should be the V out is either the plus VCC or minus VSS. So we can say that is the logic 1 and that is logic 0. Is it clear? Now when the we are getting the VCC and when we are getting the VSS, if positive voltage is greater than negative voltage, we are getting the VCC. And if negative voltage is greater than positive voltage, then we have a VSS or minus VCC. Okay, that we already covered. So we have to generate a PWM signal. So that means the operation amplifier will behave in a positive feedback. Now, if I generate a signal, one is the sinusoidal signal. This is my sinusoidal signal. Okay, and I generate one particularly RAM signal in it. I'll just say that this is my RAM signal. Okay, and we apply a sinusoidal signal on a positive terminal, and if we apply the ramp signal on a negative terminal, so what is happening if positive signal, that means the sinusoidal signal is greater than the ramp signal. So from that particularly point to this point you can say, not from this point up to this point, you can say this point, you can say your sinusoidal signal is higher than the ramp signal. Why? Because when it is ramp signal is this one, sinusoidal signal is higher than. Ramp signal is this one, sinusoidal signal is this one. So if you check the every instant of the time period, you can say that till this point, your sinusoidal signal is higher than the ramp signal. So that means from this duration to this duration, our sinusoidal signal is higher. If sinusoidal signal is higher, so that means positive signal voltage is greater than negative signal voltage in this duration. So we are getting a magnitude of 1. Okay. Now from this duration to this duration, your sinusoidal signal is lesser than the ramp signal. So that means till this duration it is negative signal voltage is greater than positive signal voltage. So we are getting a 0. Now again from this point to this point, positive signal voltage is greater than negative signal voltage. Okay. From this point to this point, okay. Again from this point to this point, again positive signal voltage is greater than negative. So basically, your PWM signal is generated. Here you can see the width of the on cycle is different and different. So every particular durations, the particularly on signal cycle is different. So this is a PWM signal. So in this experiment too, we require two signals. One is the sinusoidal signals, one is the RAM signal. RAM signal where from where we are generated already in the experiment one. So we are using the same signal, RAM signal in a this experiment. Okay, and with the help of comparator, we create a PWM signal. Is it clear? Any doubt about the theoretical concept what we are doing in the experiment too? No doubt. Okay, so now you can ask your queries about to LT Spice from the Sayam. Sayam will be handling. He is also the TA for this lab. Okay, so if you have any doubt, you can ask the question with the Sayam. Sayam?
Yes, sir.
Okay.
Does anyone have any questions?
If
Hi,
you are
Sayam.
facing any issue, any particularly things, so just ask with the Sayam.
Hello. Hi, Sayam. I'm Aryan. Actually, I have a one basic doubt that in experiment one, we have generated a ramp signal, and as sir discussed sometime ago that we should give a ramp signal as well in experiment two. So, how we transfer from experiment one to experiment two the same ramp signal? Is there any way in LT Spice, or should I create from scratch again?
Okay, so you must have made some spice file, right, for experiment one.
Yes.
Yeah, so you can just like copy that schematic and like you can paste it in the and create a new file and paste it, or like in the same file you can continue building this PWM.
Okay,
Uh,
so at a runtime, there will be a two tran, right? First was a first experiment run, and second was a second transition analysis, right? So, is it possible to run both simultaneously?
I'm sorry, can you come again? I couldn't understand.
I am saying that when I copy first experiment and paste into a second file, then there will be a two trans. Then is it possible to run both simultaneously?
Okay, okay, two trans. So when you are running, you make sure there's only one tran. Like that one tran is enough for everything to run. So that you're saying about the spice directive, right?
Correct.
So one dot tran is enough to run for, like it will run for both.
Okay, so I should make in that way so that both will run by single try.
Yeah, like if you just ensure that all the connections are correct, then like one dot tran should be enough, and the like it'll run both the experiments together.
Oh, thank you, Sam, to resolve my query.
Aryan, one thing you also can do that you have already created the experiment one now.
Yes, sir.
So just you can convert that particularly experiment one as a single block, like you are creating one IC. Okay, you have basically created the schematic of the LM339. Similar to
Yes.
that particularly block, you can use as a experiment one also. So completely experiment one will be converted into the one component. Now you can use that component in the experiment second also.
I'm not too familiar that how I can convert
You have
experiment.
attended the previous live session where basically they tell that how we create a schematic of LM339
Yeah,
or
I
basically.
watched the recording session.
Okay, so similar way you can convert that particularly circuit also into a single schematic.
Okay,
Okay,
sir,
and
I will
second thing
try.
is that you can use that particular node. Node is also
Okay.
explained in the first particularly previous session where like you have a RAM signal. So just to give that node, and that node you can also use in the second experiment.
I tried this, sir. Like I tried the copy VRAMP node and paste
Hmm.
in second experiment, but
Hmm.
I'm not able to paste in second experiment. I don't know
Not
why.
able to explain.
Yes, sir.
That will only work. So if you create symbol and put it in the new file, only then that will work.
Yes.
Uh, Basically, in the first experiment, you can in the schematic you can right click and like you can create a new symbol. There will be an option that will just
Yeah, I watched in the recording session. They guided for this creating symbol. So is the same way?
yeah, it's the same way. So it'll again show like create a default block. It may be like a rectangle shape, and uh, all the nodes will be there. And you can save that, and so save that in the same folder. So when you create a new spice file for experiment 2, you can import the experiment 1 block as like a component, just like your LM339.
Okay, I will try to convert a first experiment as a block, and if I will get any issue, then I will contact. Sir.
Yeah.
Okay, thank you.
Sanchit, your OPM output is saturating. So can you show us what is the output you are getting? Saturating at what level basically? If you are using the op-amp in the positive feedback, so always the output will be saturating plus Vset and minus Vset. Okay.
Hello, sir.
Yes, sir.
Actually, sir, I have simulated this week two experiment, so I am confused in the frequency that we have to input in the V sign. So actually, I have put the frequency that is somewhere around 312.5 hertz. So I am not getting the exact output. Can I share my screen, sir?
Yes, yes. Same look it into this.
Sorry, sir.
Yeah, yeah, you can share. You can share.
Yeah,
सही है.
Yes, sir.
yeah. Sir, my screen is visible.
Yeah. Mm,
Hello.
yeah, 1 second. I can see your screen. Yeah. So, can you once again say what's the problem here?
Yeah. So actually, I put that frequency that gave me
I'm sorry, your voice is
in
breaking.
the PDF, the lab report. So this is the frequency. Actually, PDF, they written
Arpit,
that
your voice is breaking.
uh, yeah, form of wait. Yeah, sir. Wait. Hello.
Yeah.
Yeah. Now I am audible.
Yeah.
Hello. Yeah. Okay. So yeah. So that is the blue waveform. That is PWMP,
Okay.
and this is not
Arpit,
expected that
again, your voice is breaking, so
output
we
that
can't.
we are using is the frequency that we are in the V sign.
Arpit, again, your voice is breaking, so we can't understand what you are asking. But according to this signal, like if you are showing this signal, so that is showing somehow PWM signal is correct. Okay, from that
So
particularly, yeah.
yeah. So this is correct, right?
PWM signal is a either you can zoom a one part, so we can better
Hello.
because from that one we can say that it is correct, but you can zoom it, you can show us one particularly slot, so we
Hello.
can better verify.
Okay. So let wait. I will simulate it again. Uh,
After simulation, just zoom it a one part, so we can verify that it is the PWM is correct or not. But it's similarly somehow it is looking like the PWM signal you are getting as
yeah.
output.
Now,
Yeah, that is okay.
yeah. So now,
Along with
now
the
it is visible.
yeah. Yeah, yeah, now it is visible. Can you show the triangular wave also?
Hello. Hello.
Can you show the triangular wave also? Arpit, can you show the triangular wave also?
Hello.
Can you show the ramp rate?
Okay.
So yeah, it's look like the PWM signal, correct signal. No issue with that.
Okay. So
Because
actually, the frequency.
when your triangular wave amplitude is higher than the sine wave, you are getting a lower
Okay,
pulse, basically.
okay,
Okay, and when your sinusoidal signal amplitude is higher than the triangular signal, you are getting the 5 volt. So that PWM signal is correct, no issue with that.
okay, okay. And sir, one query is that
Yeah.
there is a 5 point in that. So like we have to add a RC filter on the output of the VPWM. So like I have created. So actually, it said you get what the sine wave is input on the input. So that is actually is exact same when you added the RC filter on the output of the VPWM. So actually, I'm getting this kind of. So is it correct, or I'm not able to
Uh,
confirm it? Is it correct or like
Basically,
so,
wrong?
what is your cutoff frequency for the low pass filter?
Cutoff frequency. Wait, I have to check actually.
10 nano.
Yeah, so it is mentioned here. Cutoff frequency you can I can choose from 1 kilohertz to 2 kilohertz.
So, 1 second, can you? So, your resistance is 82K, and so how much does this give? Second. So, 1 by RC will be your cutoff frequency. So, that is how much? Uh, and what is your input frequency?
Yeah, input frequency from where in V sign or where?
Yeah, analog input basically. V in A.
Yeah, analog frequency is 312.5 hertz.
Acha, okay. But that is fine. But like in this, they said, did they mention any in analog frequency?
Yeah, actually here in the inputs it is mentioned.
Okay, 1 second. 82 kilo ohms and N nano. So I think your 1.2 kilohertz. Okay, maybe you can. So whatever you have calculated is correct only.
Mhm.
Okay, you can. Okay, fine. Huh? You can try to increase the bandwidth. Like right now,
Okay.
if I calculate, I'm getting it's 1.2 kilohertz, close to that. You can go.
Yeah.
So you can increase that to 10 or 20 kilohertz,
Okay.
because if your bandwidth is too low, then your signal will get attenuated. That's why you are getting a weird kind of sine wave after filtering.
Okay. So you were saying this one.
just change the basically the cutoff frequencies of the low pass filter
Yeah,
and
either
try that.
uh,
Either you can decrease or increase and just check the variation, so better you can understand that one. The signal is not constructed properly because there are some noises when we convert the signal into PWM. So signal will be some
Okay.
signal will be distorted. Okay.
Now for the proper
Okay,
reconstruction,
okay,
we have to we have to choose the appropriate frequencies. Okay, if your
okay,
frequency is
okay,
not appropriate, you are not getting the exactly same six sinusoidal signal. So that is the your
okay,
work, that you have to change the frequency, and so you will get the correct sinusoidal signal again.
okay,
Okay, just increase
okay.
the frequency, and one option is decrease the frequency. Only change the value of RC. That is not a big deal.
Mm-hmm.
Okay,
Okay.
so you have to
Yeah.
change the frequency, and just better that you can, after that you can understand that how much frequency we required for a proper reconstruction.
Okay, okay, okay. Got it, sir. Thank you, sir.
So some comments in the chat box also.
Oh, one second. So op amp is saturating. So that thing again, like which op amp is it? Are you talking about? Is it the MCP one or the comparator should saturate? Like that's how that is the work of comparator. Either it should go to yeah, VDD or ground. I am not able to get PWM and output when I connect VDD to LM339. Uh, what exactly is the output that you are getting?
Sir, I am getting 5 volt output.
And
Can I share my screen?
yeah, so it's like a fixed 5 volts.
Yes, sir. It's fixed 5 volt. Sir, can you share? Can you see my screen?
Yeah.
So I have done the experiment with the block and all, but when I am trying to take the output of the PWM, it is getting straight 5 volt. But if I disconnect the VDD from the pull-up resistor, then I am getting it
Mm,
for the positive one. But for the negative one, I am not getting it.
no, pull-up resistor has to be there. That's not a problem. Let's see. Okay, one second. So with the with pull-up resistor, can you show the output?
For PWMP, it is fine with pull-up resistor, but for N, it is not working.
So actually here you have uh, you are taking output after the low pass filter, no? Like
Yeah, but before also it is not
okay,
working.
okay, it's
Before low pass,
showing. Is can you plot the V plus and V minus? Is
okay.
V
V
plus?
plus and V minus remains at 5 volt when I connect VDD at
No,
the
no.
V.
Like I'm saying, before the uh,
If I remove that VDD, I am getting it. For the positive, and for negative, it is like this.
no, no. I meant V plus A in and V minus A in.
Oh, okay.
Okay. And ramp also can you plot?
Yeah.
So those signals are correct, but your comparator is not working.
But
Are you
here, if I change the input to minus, then it is working. Output of the low pass filter is also fine. for the first comparator. For the second comparator, it is not working when I connect the VDD.
Mm, once, can you try this? Uh, can you remove the in the VPWMP, the top one? Can you remove the low pass, RC low pass?
Okay.
Just delete that. Huh. And now, can you check now?
Now it is. I am having the same problem, sir.
Still constant at 5.
But if I disconnect the VDD from the second comparator, it is working fine then for the positive one. My ramp also gets disturbed when the VDD is connected to the second comparator. This is my ramp signal when VDD is connected to the second comparator.
Okay. Why is there a resistor after the VRAM? Yeah, 1 kilo ohm resistor.
So that I have connected from the first experiment, I guess. Should I remove and try?
I mean, like,
Like a load resistor I have connected.
yeah, you can remove that. I think that is not needed.
Still, the RAM signal is like this.
So when you have that load resistor, the ramp is coming properly.
No, without that also it is coming. If I remove the VDD from the second comparator, hello sir.
Yeah. I'm thinking what could be the issue.
Sir, I tried the same thing without this block thing. Uh, this circuit also has the same problem.
But the ramp is generated correctly.
Ramp is generating correctly when VDD is not connected to the second comparator for both the circuit.
Then, like, can you just remove pull-up resistor and check
For the second comparator, no?
for both?
Both. Now I am getting some output, sir.
Is the LM339 properly uh, connected?
Yes, sir. Hello, sir.
Yeah, yeah, I'm here. Can you show the circuit once again?
Yeah.
It looks like if you connect that pull-up resistor, the VDD value is going to V out.
Yeah. Sir, but in the first comparator, if I put the input of V plus in and V minus in, it is working with the pull-up resistor and with RC circuit also. But for the second, this thing it is not working.
Hmm. Connect VDD once.
It's 5 volt constant.
Loading is happening, I think.
Maybe try making a separate net just for that VDD in case that is somehow causing an issue.
I have tried that also.
That also doesn't work, huh?
Ah. Oh, sorry, I have to connect to the ground.
And the top PWM also is 5?
Yeah.
Huh. Are the VDDs still correct? Like, are they still 5 volt?
Yeah.
Right.
Now I am getting some output from, but it's from minus 540 millivolt to 0 volt. When I did the ground separated the ground.
Yeah. That's still not supposed to be the case. So for the bottom PWM, can you show both the inputs and the output all in one thing?
Yeah.
And the output also? Yeah. So the switches are happening at the correct times, but for some reason the saturation is getting messed up.
Yeah.
Like the pulse width is correct, but it's oscillating between the wrong values. Is the VDD of U3 exactly 5? Just if you click on
VDD
that.
by 2.
Of U3, the one that's going in.
Yeah, this one, huh?
Yeah, just if you can probe just that VDD terminal. That's the current through it. I think just move the voltage source a little to the right, and then there'll be a wire. So that's misbehaving.
Sorry, I have not set the 5 volt.
Oh, right, yeah.
Still, it is
Right.
not
So
correct.
I have them. There may be an issue in like when you made the symbol, you might have assigned the output to the VDD and the VDD to the output, maybe.
But then it should not work for the first comparator, no?
Right.
Maybe you can try increasing the pull-up resistance, maybe to 5 kilo ohms.
Still, it is same.
So the top one is coming correctly.
Yeah.
Then so top one has VDD, right?
Yes, sir.
So put VDD in the bottom one as well.
Now I am getting constant 5 volt.
Okay, maybe one issue might be that so you can, instead of uh, naming the node as VDD, like in the V1 voltage source,
Huh.
you can change that like a port type and make it like uh, output.
Okay.
And here make it input.
Should I change for the whole circuit? Still, it is same issue. But I am getting the V in and V in plus and V in minus. VAN. Ramp I am not getting when VDD is connected.
And can you check the VDD terminal of U3 again? Just trying stuff.
It's 5 volt now.
Okay, now it's a proper 5 volt. And the output is also 5 volt.
Yeah. Output of first comparator is also 5 volt now.
Yeah.
But if I remove the first VDD and run it, I am getting the correct output from the first comparator for both V plus A and V minus A.
Right.
And VRAMP is also correct for that.
Right. And for some reason, just changing something in U3 is affecting the entire circuit.
Yeah. I have tried copy pasting the same thing here instead of manually doing. Then also the same problem.
Right.
Maybe one thing you can try is use a maybe use a different op amp instead of comparator instead of this LM339 or the LT Spice. So when I did this experiment, I used a different component.
Sir, can you name
Yeah,
the
I'll one second.
Try LTC 6572, I think, or 6752.
Yeah, the same one. Yeah.
LTC
6752.
67?
It's worth a shot, I suppose.
Oh, now it's working.
Okay. And put VDD at the pull up also.
Uh, Yeah,
Okay, and the other output?
I'm getting it.
Okay. Now put the RC thing also on, just to see if it still works.
Now the Vout is not proper for the first comparator. Should I change that for LM339 also?
Yeah, go for it.
Now it's okay.
Right. Yeah, cool. But it's still weird how the other one didn't work. But yeah, this should be fine then.
Thank you, sir.
Any other doubt related to the lab part?
Sir, on the lab manual, it is written with to do with LM339, but I have changed the part. But it is not. It is okay, right? For the
Yeah,
video.
yeah, no problem with that.
Okay.
So I think no doubt. So we will stop here.
Sir, one more doubt, sir. Sir, I have done that with by converting the first circuit into a component, and then should I share that component file also?
Yes, exactly.
Okay. So the component file and the second
Without that
experiment.
component file, it is not possible to verify.
Okay, sir.
If anyone want to verify that one, LT on the LT spice. So without that component file, we can't verify that.
Okay, sir.
Yes, anything? So thank you, Daniel. Thank you, Sayam.
Yes, sir.
Sure, sir.
Thank you all.
Thank you, sir.
Thank you so much, sir.